I'm Jonathan Sabo. I'm a senior solutions architect at Tigera. Today we're going to be going over getting up and running with Calico in an on-prem environment. And we're going to talk through some of the considerations that you need to take into account when you're planning out your Kubernetes deployment, and specifically some of the stuff with Calico, if you choose Calico as your CNI. We've gone through this, we've done this this specific training session a few times, and it's available on our YouTube channel, along with a lot of the other training events that we do from time to time. So if you have to leave early, or you're interested in checking out Project Calico's YouTube channel, you just search for Project Calico in the YouTube search, and you'll find all of our videos there. You can also search for Tigera. So we have two different YouTube channels. We've got Project Calico and the Tigera YouTube channel. When we're done with the training here today, we'll email you out the slide decks, and we'll send you guys all a link to, or you folks all a link to the video. There's a couple other ways to participate along with the Project Calico community. We are at projectcalico.org. We also have tigera.io and docs.tigera.io for enterprise documentation. If you follow us on Twitter at Project Calico, if you're interested in writing some code, maybe helping improve documentation, or want to open up issues, we're at github.com/Project Calico. And if you're interested in maybe getting some real-time help, or you have a question, you can join us on slack.projectcalico.org, and you will be amongst around 4,000 or so other Kubernetes operators. Our developers and engineering team hang out in there, and as time permits, we'll field questions and kind of address any issues that come up. We try to be kind of responsive there in the various channels. Project Calico is by far the most widely used Kubernetes CNI in the world. We have over 150 contributors who have contributed to Project Calico. Project Calico powers well over 1 million nodes and over, I'd say, like 180,000 known Kubernetes clusters. So it's very widely deployed, it's battle hardened, tested, and it's used across enterprises all over the world today. Today, what we're going to do, we're going to go over a couple of different things. We're going to talk about Kubernetes and Kubernetes networking considerations, Calico networking considerations, and then what we're going to do is I'm going to run through a lab that I have that's publicly available in our GitHub, along with some of our other training labs are up there as well. And I'll paste that link into the chat here in a bit. Well, what I'm not going to do today, I'm not going to go through the installing it live. We're just going to kind of walk through it. And I want to explore the Kubernetes with Calico networking considerations, and just kind of talk through some of the different options that are available, and point you to some resources that we have available online. And as part of the lab, there's a simple Calico network policy example at the end. If you have reached a point in your Kubernetes journey where you have you've got your cluster up, and you've got networking figured out, and now you're starting to release applications to your cluster, and you've realized that, hey, inside of Kubernetes, by default, everything can talk to everything. And you have a reason to be able, you have to segment workloads from one another. You have to create security boundaries and control who can talk to who inside of the cluster. That's what Calico network policy is great for. It's super high performant network policy enforcement, and it does so with the Kubernetes in a Kubernetes native way, using labels applied to pods, well, to the endpoints inside of your cluster, using labels on namespaces and also service accounts. You can see the link here at the bottom. That is the on-prem Kate's Calico OSS instructions for the lab at the end. There's a note at the top. If you're just getting started with Calico, we have a quick start. That's probably the best thing to start with, but we also have a opinionated lab that walks you through how to get up and running with kubeadm, in a scenario where all the nodes are on the same network. So let's kind of get into this. So when you start, when you deploy your Kubernetes cluster, you begin to think about, hey, I want to deploy Kubernetes. There's some considerations that you need to take into account as far as the networking. The first one is which CNI should I use for my cluster? I mean, the obvious answer is Calico, of course, but there are other choices. And so I wanted to kind of describe a little bit about what makes Calico special and why you would choose to use Calico over any of the other options. Calico, as you saw on the slide, the previous slides, it's used by everybody. If anybody, most telcos, a lot of large enterprises, and a lot of banks, a lot of I don't know. There's over 180,000 known clusters that are using Calico every day for production workloads. And dev and test as well. So it's super, it's used everywhere. And as because of that, it's very reliable. We hear from our customers that we work with quite often that Calico is great. We haven't had any problems with it. It just runs and does what it does. It's kind of boring, which is if you're operating a platform, that's kind of the situation you want to be in. You don't want lots of surprises. Calico has a couple of interesting superpowers. The open source Calico. What you can do with Calico is you can peer with your on-prem data center network, and what that allows you to do is to make the pod sider, your endpoints inside of your Kubernetes cluster, first-class citizens on your routed network. So you can advertise your pod sider and your service sider, and this allows you to use native routing protocols, BGP specifically, that networking teams use every day. This is it's higher. You'll see a greater performance using that configuration because you don't have to use an overlay, and we'll talk a little bit more about what some of those mean in a moment. When you deploy a Kubernetes cluster, there's a few different things that you need to decide when you initialize your cluster. One of which is the pod sider. What is the address space that I'm going to allocate for this cluster that is going to be used to assign IP addresses to pods? Kubernetes is a flat network, and pods and Kubernetes are the Kubernetes network, and they're meant to see each other from the IP addresses that are assigned to the pods without NAT. So pods are assigned an IP address, and they connect to each other via those IP addresses as your microservices communicate across the different nodes that you have in your cluster. So I'm not aware of any distribution that allows you to change these settings after the fact. There's two settings that are kind of chosen at cluster install time, and in order to change these, I'm pretty sure you have to build a new cluster and then migrate to it. So you want to be sure that you've allocated enough address space for all of the workloads that are going to run in your cluster. And that's kind of like the second bullet point, or the third bullet point here. How big should this pod sider be? And will it be private or externally routable? As far as how big should it be, you have to consider how many nodes are going to be in my cluster, how many pods are going to run on each one of my nodes, and then do I have enough address space to be able to allocate IPs for each individual endpoint that's going to run inside of my cluster. So those are some of the considerations that you will take into account. You want to make sure that if you assigned your cluster a /24, that's only 256 IP addresses. If you've got 100 nodes in your cluster, you're going to run out of address space pretty fast. So you need to be able to allocate a CIDR that's going to allow you to grow into the endpoints and the applications that you deploy into your cluster. And we'll talk a little bit more about that in a minute. And then we have to decide also, is the CIDR that we assign to our cluster, is this going to be private or will it be externally routable? when you're using Calico, you have the option to be able to peer with your top of rack switches and advertise that address space. And so if you're planning on integrating with your networking fabric, you're going to want to make sure that the address space that you assign for your pod sider doesn't overlap with other clusters, or it isn't overlapping with other infrastructure on your network. So you're going to want to make sure that you allocate the siders and you track that and make sure that things aren't overlapping, so you can make sure that everything can be routable. Or you have the choice of keeping everything private. And by choosing to keep your cluster private, you can use the same pod sider again and again for all of your clusters. And there's a lot of reasons why people end up with more than one cluster. Typically, people will start off with like a dev cluster, and then they'll create one for staging, and then another one for production, and they'll roll their applications out in that release stage manner. There's also sometimes we talk to teams that utilize new clusters as a means to achieve multi-tenancy for various reasons. Or sometimes you might have just one big cluster, and you're using things like Calico network policy to satisfy all of the security requirements around, or some of the security requirements that enable you to achieve multi-tenancy in a minimal amount of clusters. Another reason why people will have a lot more than one cluster is just availability concerns. The control plane is scoped to a single cluster, so you could have you might want to have at least two if you're doing upgrades. I think that's a pretty good best practice that we see a lot of people implement. The second choice that you typically have to make upfront at cluster initialization time is the service sider. So Kubernetes services, services are a construct inside of Kubernetes, and what they do is they load balance traffic to pods behind them. And you can see over here in the diagram the smaller little orange orbs there. Those are meant to represent services, and services are actually implemented in Kubernetes by a thing called KubeProxy. And KubeProxy has a couple of different modes. The two modes that are probably the most widely used are IP tables and IPVS. By default, I believe IP tables is still the default KubeProxy mode, and what it does is it will NAT the traffic to the pods behind it. So you can do things like kubectl get services, and you see your services, and then you can do kubectl get endpoints, and you give it the service name, and you can see the endpoints behind that service, and those endpoints are pods that are running in your cluster. So it's basically a free load balancer that you get for free that comes with Kubernetes. There's a couple of different service types. There's the service type load balancer, cluster IP, and node port, and there's some nuances as to how those all work. But that's kind of outside the scope of what we're going to talk about here in this slide. As far as the Kubernetes networking considerations, you're going to want to pick a service sider that's going to allow you to have enough IP addresses for all the services in your cluster. Now, in most people, I think they'll find that you have way more pods than you do services. But services are another construct inside of Kubernetes that do consume an IP address. So you want to take into account how many services am I going to have in this cluster, and is the sider that I'm going to use, is this enough IP addresses for all the services inside of my cluster? And then also, when you choose the KubeProxy mode for your services, if at a certain scale, around, I think it's, and I'm going to show you a blog that we did on the performance benchmarks of the different KubeProxy modes that we have published on our blog page. At a certain scale, I think it's either 1,000 or 10,000 services, you do start to see a noticeable difference between IP tables and IPVS. And IPVS was actually added in to address that scalability issue and kind of give you more performant KubeProxy and service implementations. There's actually another option here as well, and that's just to not have KubeProxy be part of the solution. And you can achieve that with Calico and Calico Enterprise eBPF's data plane, and we'll talk a little bit about that in a moment. So after you've chosen your pod sider and you've chosen your service sider and you've decided on your KubeProxy mode, the next thing that you're going to want to decide is, okay, what are the Calico networking considerations that I have to decide as part of this cluster, this Kubernetes deployment? Which Calico data plane do I choose? So Calico has a few different data planes. They have the standard Linux data plane. And what that does is Calico, it's not really in the path, the data path. What Calico does is it dynamically programs the Linux kernel, and it will program routes and assign IP addresses for the pods inside of your cluster, and it also will can segment traffic using IP tables, IP sets. So it's super low latency, very high performance networking and network security enforcement with the standard Linux data plane. If you're not running like RHEL 8, or you have older versions of Linux that you're running in your cluster, you might not have the requirements to be able to use the latest, greatest Calico data plane, which is our eBPF data plane, which is uses a new technology called eBPF, and I have some links to that later on in the GitHub repo that was shown, and I'll paste it into the chat here in a moment. The eBPF data plane has some other functionality that might be of interest. It makes it a lot easier to be able to see the source IP of clients, and it enables things like direct server return. It's also just higher throughput, less CPU utilization. Calico, with the standard Linux data plane, there's some independent third-party performance benchmarks and out there. You'll see Calico, it ranks the absolute best as far as cluster utilization. It uses the least amount of CPU, the least amount of memory, as compared to some of the other options out there. And then lastly, we also have just recently open sourced our Windows data plane, the HNS, I think HNS or HMS data plane for Windows. We have we've open sourced the VXLAN data plane, and I believe the BGP data plane will be out here shortly, if it's not already. So if you have Windows workloads that you want to use for inside of Kubernetes, you can use Calico for that, and you can use VXLAN, or you can also use BGP. And so your Windows nodes too can peer with your top of rack switches, which is really cool to see with Windows. If you have a mixed cluster, some Linux nodes and some Windows nodes, you can use things like node selectors to make sure that the pods that belong on Windows end up on the right nodes. And so we have 3 different data planes that you can choose from based upon your requirements or what you're hoping to achieve. We also, you need to determine whether or not you need to do network encapsulation. And one of the considerations one of the things that will determine that is, are all of the nodes of my Kubernetes cluster on the same subnet? Do they have layer 2 adjacency? If the answer is yes, you can turn off encapsulation. If the answer is no, then you can peer with your top of rack switches, and then allow BGP peering in the fact that you're peered with your top of rack switches to route packets across the network boundaries across subnets, and that would allow you to continue to have network encapsulation turned off, which is probably the most performant option. If you have either all of your nodes are on the same subnet, or you are peering with the top of rack switches. If they're not, you can choose to enable encapsulation. Calico supports a couple of different tunneling protocols, IP and IP, and also VXLAN. And Calico will tunnel across nodes, across the network boundaries in a smart way. There's three choices. You can turn NCAP off, you can enable it on always, or you can say across subnet. So if some of your nodes are on the same subnet and then some of your nodes are on a different subnet, you can do cross subnet. So only the traffic that goes across that routing boundary, across that subnet boundary, that's the traffic that gets tunneled. And then the nodes that are all on the same subnet, they don't need to. And so you kind of get like the absolute most performant implementation for your cluster. There's some on our YouTube channel, on the Project Calico YouTube channel, there's a couple of videos that show everything that you would ever want to know about Kubernetes network in AWS, Azure, GKE. Definitely go check this out. We kind of show you how packets move around the cluster in the various NCAP modes, VXLAN, IPIP, or no NCAP. So another consideration is, what do I choose for my initial IP pool CIDR? So this is one of the other cool things about Calico. So when you choose your pod CIDR and then you choose your service CIDR, when you use Calico, you can break up your pod CIDR into chunks. So imagine you assign your service or your pod CIDR a /16. You could choose your initial IP pool to be a /24 out of that /16. And so, and by doing that, it allows you to create more IP pools. And so IP pools what they are is a construct, a Calico and Calico Enterprise construct that allows you to determine whether or not NAT outbound is enabled, whether or not NCAP is enabled. And it also makes it add some flexibility. So you create an IP pool and the default IP pool that as you launch a workload into your cluster, the pods come up and they get an IP address. By default, they're going to get an IP address out of the default IP pool. But you can create more IP pools, and you can do things like assign them to namespaces. You could say workloads in this namespace get IPs out of this particular IP pool. And workloads, so if you've got a dev namespace and you've got a staging namespace and a prod namespace, you can create IP pools, and you can use labels to select the namespaces and say, hey, IPs, pods in the dev namespace get IPs out of this first /24, IPs out of prod namespace get IPs out of this other /24. And if you're peering with your top of rack switches as traffic leaves your cluster, your workloads will have well-known IP addresses, and this kind of sets you up for success when you have to integrate with things outside of the cluster, like firewalls. If you have traffic leaving your cluster, your firewall administrators can say, hey, it's out of this particular CIDR. We know this comes from the dev IP pool. These are the dev workloads. They can talk to the dev database out past the firewall, or these are the prod IP addresses. So, and there's other reasons why you would want to kind of create more than one IP pool. It allows you just more granular control over the IP addressing inside of your cluster. So you have to decide, do I want to assign specific IPs to pods based on the node that they happen to be running on, or the namespace that they happen to be running in? That's some of the power that you get with Calico IP pools. And then when you create an IP pool, you can decide what is the initial IP pool block size that I should use. If the default, I believe, is a /26. So if you created an IP pool with a /24, Calico is going to take a chunk out of that IP pool, that initial IP pool, the size of the block size that you choose, so by default a /26, and it's going to assign it to every node inside your cluster. So when you install Calico, the first thing you'll see if you do Calico IPAM show is you'll see a /26 allocated out of the IP pool for every node in your cluster. And then you'll also, one of the other settings for IP pool is NAT outbound. Should I disable NAT outbound? And this is kind of where you decide, is my cluster CIDR private or is it public? When traffic leaves my cluster, by default, if you have NAT outbound enabled, if you've chosen to have a private cluster, as traffic leaves the cluster, it's going to get source natted to the IP address of the node that pod was on. So as traffic leaves, it's going to get natted to the IP address of the node that it's on, and then it's going to leave the cluster and go off to wherever it's headed. And then when it comes back, it's going to get reverse natted back to the pod IP address, and Calico and IP and KubeProxy will handle all of that. But this is kind of this is the setting that determines whether or not your cluster CIDR or your pod CIDR is private or not. All right, so once you've chosen your pod CIDR, your service CIDR, and your initial IP pool, and you initialize your cluster and you join your nodes to your cluster, and you have all of your nodes are ready, and your pods are all assigned IP addresses via Calico, and you started to deploy your workloads to your cluster, you might want to be able to segment who can talk to who inside of your cluster. And that's where Calico network policy comes into play. What we've done here as part of the lab that I'm going to go over in a minute is we've added a simple Calico network policy example that you can take out, you take a look at, and you can deploy into your own clusters that you stand up and kind of just take a look and see, how does Calico network policy work. Calico network policy, what it does is it secures the applications by enforcing which network traffic is allowed or denied using label-based rules. And why is network policy important in Kubernetes? Well, it allows you to meet the security criteria that you might have for workloads that are running on VMs or bare metal outside of your Kubernetes cluster. So as you move workloads from VM-based implementations or bare metal-based implementations, and you're starting to embrace microservices architectures and containerizing your applications and deploying that into your cluster, your security team and your networking team is going to want to make sure that you have some way to be able to control inbound and outbound traffic. And that's what Calico network policy does. It will help you segment your workloads, and that will allow you to meet your Kubernetes or your security criteria, and then everyone will sign off on your deployments and you can move into production, instead of saying, hey, we need a way to secure these workloads. So Calico is there for. And what's special about Calico network policy? Calico network policy is kind of it's a superset of Kubernetes network policy. It allows you to control not just inbound access, but also outbound access. It does so using labels that are applied to the pods, the endpoints, but also namespaces and also service accounts. It allows you to control UDP, ICMP, TCP, and some other streaming protocols. It allows you to use things like in the enterprise product, you can actually even use DNS names for egress access. So there's a lot of advantages to using Calico network policy instead of just plain Kubernetes network policy. It's a superset of Kubernetes network policy, so you can implement anything that you would normally do with Kubernetes network policy and above and beyond that. And with Calico Enterprise, there's some additional features like policy tiering. If you're working with multiple teams and you need to be sure that, hey, we have a platform team and we've got a security team, they can create a tier that gives them first say on policy enforcement in your cluster, and then delegate responsibility to development teams and allow them to manage the network policy for their microservices with the knowledge that the platform team and the security team have made sure, hey, we're not going to put the availability of the cluster at risk. If a developer creates a certain network policy, because the platform team is already ensured that the traffic that is required for the cluster to stay up is already allowed in a higher tier. and we can be sure that the teams that are collaborating on network policy aren't going to put the cluster at risk security-wise, because the security team has a tier that's higher than the developers' tiers, and they are denying or allowing the traffic that they've determined is important for the security of their Kubernetes clusters. The sample Calico network policy example that we have in the GitHub repo, it has an example that is meant to secure a typical 3-tiered application that you might be developing inside of your own cluster, where you have a front end, a couple of microservices behind it, like a web front end, a couple of microservices that implement like the business logic of the application, and then those connect back to like a backend database. And what we've done as part of the policy example is we've implemented a zone-based architecture that will be familiar to most network engineers or teams that are working in enterprises, where you're probably familiar with the concept of a zone-based architecture, where you have like this stovepipe where the top zone, the DMZ, it kind of goes from like the least secure to the most secure, or the least trusted to the most trusted. So the DMZ, where you might have things like Kubernetes ingresses, or you might have just straight access to the internet, inbound access to the internet, and then you have a trusted zone behind it, and then behind the trusted zone you have a restricted zone where you keep things like databases. The network policy example implements this zone-based architecture inside of Kubernetes using Calico network policies, and you can deploy this to one namespace or 2 namespaces, and every namespace can have its own zone-based architecture, or it can be implemented using namespaces. You could say namespaces with this particular label are in the DMZ, namespaces with this particular label are in the trusted zone, namespaces with this particular label are in the restricted zone, or you can say pods inside of this namespace with this label are in the DMZ, pods inside of this namespace with this particular label are in the trusted zone, pods inside of this namespace with this particular label are in the restricted zone. So it's a couple of ways to implement a very well-known zone-based architecture inside of your clusters. And then, of course, Calico network policy enables default deny inbound and outbound. So if you've embraced zero trust networking, zero trust network security, and want to start off with just default deny either per namespace or for the entire cluster, that's absolutely possible to do with Calico as well. And that allows you to just, instead of having everything in a particular zone, allowing inbound and outbound access and trusting trusting connectivity inside a particular zone, you can say, I'm not going to trust any connectivity, and I'm only going to allow inbound and outbound access that's required for this application to function. And so basically a complete, like a least privilege policy, network policy, zero trust network policy enforcement. That's really easy to do with Calico. And with Calico Enterprise, actually, we have a thing called policy recommendation. So when you install Calico Enterprise into your cluster, we're watching all of the flows across your cluster, and we can see who's talking to who. And then we can take that data and we can recommend to you a least privilege network policy based on the observed behavior. So it kind of gets you started really fast with a least privilege network policy. If you're interested in trying out Calico Enterprise, you can sign up for our free trial. It's at tigera.io/trial. We have a self-hosted trial. So you can, we have a hosted trial where you can use nodes that we provision for you. And we have some canned use case workflows that you can go through and try out the policy auto creation, try out preview and staging policies, which is one of the other features in Calico Enterprise that's really powerful. The ability to create a network policy, and then instead of enforcing it immediately, potentially breaking the traffic and causing an outage, you can stage it first. And you can see, hey, what would this do if this was enforced? And you can take a look and see, like, all right, is this going to deny what I want it to deny and allow what I want it to allow? And then when you've let it bake for a little while and you're happy, or the right stakeholders have signed off, you can promote that stage policy to an enforced policy, and it adds just like some more guardrails around policy management life cycles, and kind of making it easier for teams to empower developers to manage network policy. There's also a bunch of policy troubleshooting and visibility capabilities that comes with Calico Enterprise. And then in one of the next versions that'll be out here, there's some different visualizations. We have a flow visualization tool, and we have some service graph visualizations. We also have policy for external access controls. So if you have like east-west, so that we do Calico in the cluster, east-west microsegmentation, but also north-south, stuff coming in and leaving the cluster. And then we have some baked-in compliance reporting, continuous compliance, some compliance reporting around the traffic inside of your cluster, also the auditing of who's managing the network policy. All of that stuff comes with Calico Enterprise, and you can try that in a hosted environment, or you can actually add your own cluster to Calico Enterprise, and you can try that out on tiger.io/trial. Before I hop over to the Git repo and kind of walk us through the lab, we have some additional upcoming events. Later on this week, we have egress access controls for Kates, getting up and running with Calico for Windows. If you're interested in learning more about the Windows data plane, that was recently open sourced. We'll be doing that on the 10th. You can see how Calico Enterprise, in some of the guardrails we were talking about a minute ago, enables you to further multi-tenancy. So if you're currently in a situation where you're standing up a new cluster for every application or something, and you've realized, hey, doesn't scale and this is really expensive, we can help you secure workloads inside of one cluster and enable multi-tenancy. We have a lot of customers that have worked with us over the last few years to be able to kind of consolidate the number of clusters that they need while meeting the security criteria for their applications. So definitely check that out. And then on the 17th, I'm going to be back doing multi-cluster management. If you have more than one Kubernetes cluster, maybe you have one per region in AWS, or you have one per region in Azure, as long as you have one per region in your on-prem data centers, and as long as you have routable connectivity between your clusters, we can actually federate the endpoint identity across all of those clusters and use Calico policy labels to control who can talk to who across clusters, which is a really cool superpower that is part of Calico Enterprise. You can also federate services. So if you're looking at doing like global service deployments, and you want to do so without the complexity of service mesh, you can use Calico Enterprise Federated Services. So you can create a service that's well known to across clusters across all the regions, and everybody connects to the same service endpoints, and the backend endpoints could be in one cluster, or it could be across as many clusters as you want to add. And so it's a very simple way to achieve multi-cluster failover, global service failover, and global service discovery. So we'll get into that. And then if you're interested in digging into KubeProxy, or you want to hear more about Calico Network Policy on OpenShift specifically, that's coming up as well. All right. So I'm just going to go over the lab. Let's kind of walk through the GitHub repo. I'm just going to paste this into the chat. Can hear. I saw that there was a question here in the Q&A. Let me address these questions real quick. I have a question about outgoing traffic. Is it possible to attach specific public IP for each pod, because my production needs to have route outgoing traffic over multiple outgoing public IPs? Yes, you can. There's a couple of different ways to do that. So if you create an IP pool, you can actually use labels to say, hey, this pod is going to get an IP out of this IP pool. And so you can kind of like statically assign an IP address to a pod or pods inside of a namespace. So that's one way of doing it. That's really, if you're in an on-prem environment where you're peering with your top of rack switches, that will work out perfectly for you. Also, if you're peering with your top of rack switches today, we have a thing called egress gateways. And what egress gateways do is they allow you to deploy an egress gateway to a particular namespace. And then you can, using labels, you can say, hey, this pod's in this namespace, or this specific pod needs to go out of this egress gateway. And so it allows you, and then the egress gateways, what they do is they NAT. So they're going to do NAT outbound, but that's a way to have a well-known NAT IP address. Instead of like any random node that's in your cluster, you can say it's going to be the IP address of these egress gateways, and you can say this particular workload will use this egress gateway. So traffic leaves, it's going to get natted to the IP address of the egress gateway and not the node. And that will allow you to take that egress gateway IP and go plug that into your firewall outside of the cluster. You can also just enforce policy at the source inside of your cluster. But if you need defense in depth, or you need that to control traffic outside of the cluster via like legacy network security controls like firewalls, or then you can give your application well-known IP addresses using IP pools, using egress gateways, and even I think there's probably some other ways. We also have an integration with Fortinet firewalls specifically. If you check out our docs.tigera.io, if you happen to be a Fortinet customer, we have the ability to populate dynamic address groups inside of FortiGates with the IP addresses of the pods or the nodes that workload happens to run on. And then the firewall team can use those dynamic address groups inside of their policy rules to control traffic passing that firewall. So there's a couple of different capabilities that we enable, some of which is open source, and then some of this stuff is part of Calico Enterprise. And you can go try out Calico Enterprise with your cluster on-prem, with Rancher. There's a couple of different options. You can do it with our hosted trial, or you can also use your self-hosted Calico Enterprise trial if you want to check it out. And or also just send us an email, and we'd be happy to kind of talk to you about that after the fact. So I wanted to show the lab here. I pasted the link into the chat. I'm just gonna kind of go through this here. So this content was built for free training workshops. If you're looking for the general docs for Calico, we recommend that you start at the quick start. The quick start uses VXLAN and for tunneling, which is going to work everywhere. That's like that's probably your best bet for success. If you're just getting started and you're not really sure what you want to do yet, definitely go through and do that. But if you have come through this lab and you've seen that you need to choose, you need to decide up front your Kubernetes networking considerations. You need to decide up front your Calico networking considerations. You need to choose a pod sider. You need to choose a server sider. You need to choose which Kubernetes or kubeproxy mode to run in. You need to choose which data plane to use, what the IP pool sider is, the IP pool block size, whether you're going to do NAT outgoing, and then whether or not and how to determine if encapsulation is required, right? So these are the questions that you will need to ask yourself and then decide. And then as part of this lab, we've made some decisions. We chose a pod sider, we gave it a /16, and then we gave it the server sider another /16. And you can see that these are not overlapping. You want to make sure that your pod sider and your server sider are not overlapping. And then I've chosen IP tables for my kubeproxy mode. The initial IP pool, I'm going to choose a small block out of the pod sider. So this sets me up so I can create more IP pools. And I can, and there's a lot of flexibility that you get with by managing things in that way. And I'm gonna leave the default block size, the default NAT mode, and also I'm going to you can actually allocate additional IP pools. So you can see that this first /24 is 10.48.0.0/24, and the next one is 10.48.1.0/24, and then I can do 10.48.2.0, 10.48.3.0, and I could create a /24 for every one of my namespaces if I wanted. I'm going to come up here and take a look at one more question here. It says just a quick thank you, and can we utilize DHCP where we don't have a static network already pre-allocated? Not for Kubernetes, not for the pods. In Kubernetes, the CNI and the IPAM management that comes with your CNI, or you might have a third-party IPAM management. solution, or you might be doing like host local, where you can statically assign a net block to a particular node. But I'm not aware of any that utilize DHCP. Maybe though, I know that there's an info blocks IPAM management, and maybe that does something like that. I'm not sure. Calico IP address or IPAM, yeah, it does some special things. One, it makes sure that there's absolutely no unused IP addresses. So imagine if you chose to do like host local IPAM, and you said, I'm going to break out a /24 for this host, and then for this host, and then for this host, and then you've got a couple of hosts that have got a ton of workloads on them, and and then you've got a couple of hosts that aren't doing anything, and you want to deploy some more workloads, but you're out of IP addresses on these certain nodes. If you use Calico, you can actually have Calico can do this thing. It can do IP borrowing, and it can borrow unused IP addresses from the nodes that don't have any workloads on them. And so you can make sure that there's absolutely no unused address space. That's one of the benefits of using Calico for IPAM. Also, you can view and see, like you can use Calico Cuddle and do Calico Cuddle IPAM show and IPAM show -- show blocks. And you can see and monitor and manage and like monitor and be alerted to the IP address utilization. So you can know ahead of time, like, hey, I might be running out of IP addresses. I need to do something. So there's a lot of reasons to use Calico IPAM. I'm not aware of any where you would use DHCP. You can use DHCP to assign the IP addresses to the nodes that you use for your Kubernetes. And then you could choose to keep your Kubernetes pod and service siders private if you wanted to. So you have a lot of options. Just kind of run through the installation. So if you're installing this particular installs with kubeadm, all of the nodes are on the same network, and it just goes in. This will just get you up and running with a kubeadm installation, and then this will allow you to initialize your cluster using our chosen service sider, our chosen pod sider, and if you want, you can reset and start all over. This will initialize the cluster. You can copy your kubectl in place, and this will allow you to use kubectl on your master node, and you can talk to your Kubernetes API server. And then you'll go through and join each one of your worker nodes. You'll see that you come and join each worker node, and then eventually you'll see that if you do kubectl get nodes, you'll see that they're all up, not quite ready. Once you add the Calico operator, Calico has a couple of different installation methods. I believe we have a Helm chart, we have a manifest install, and then the latest way is with our operator. The operator is awesome. It makes the Calico operator manage itself. So the Kubernetes installation is managing itself. It makes upgrades really easy. And then there's some configuration in the custom resources.yaml, where you will choose the block size and the initial pod sider. You will choose whether or not to enable encapsulation, or whether or not your cluster sider is going to be private. And if you have outgoing enabled, it will remain private. And then you apply it, and then you'll see that the pods will all come up. And then after you're done, if you do Calico Cuddle node status, you'll see the nodes that will be up here. You can take a look at the IP address pool, and you'll see that the definitions that you defined here for your installation here will be realized inside of your cluster, and you can look at your IP pool, and you'll see that this is what's actually deployed. And you can do things like Calico IPAM show, and you can see the default IP pool, and you can see how many IP addresses are in use, and then you can look at the blocks, and you can see how many are in use across all of my nodes. And as I mentioned, you'll see that the default block size, it's going to break out one of those blocks, and it's going to assign it to a particular node. And then you can take a look at the network policies. And if you come down, you'll see that we've got a network policy example for you here. And then I wanted to point out the references at the end of the lab. There's the quick start that for our install that's mentioned at the very beginning. That's here. The differences between comparing KubeProxy modes. comparing kubeproxy modes, IP tables versus IPVS, you can get a sense of the performance comparison between the two. And you can see here where as the numbers of services increase, when you start to hit around, I guess, 10,000 services or so, you might want to consider, hey, maybe I want to move from IP tables to IPVS, or I want to check out the Calico Enterprise eBPF data plane. And then also the CPU utilization as the number of services increase, and then some of the conclusions. I mentioned the Calico eBPF data plane. There's a link at the bottom. This was open sourced a while ago. It's now GA in open source Calico Enterprise. So if you have one of the later kernels, you can take advantage of this. It allows a higher throughput, uses less CPU per gigabit, and then it has native support for Kubernetes services without the need of kubeproxy. And what that allows you to achieve is it reduces the first packet latency. And that's important because even with IP tables, the real the impact really where you see like a performance hit is that first packet, because after that you're using Linux contract, and so it's like it's a open source stateful firewall. So the second packets are just going to move right through without any with a like, I don't know, a much decreased latency. It also makes it really easy to preserve the client source IP address, so you can get more intelligence on like, hey, what is the source IPs that are actually contacting me without the NAT that happens with kubeproxy. It also supports things like direct server return. A lot of times, like we work with a lot of telco customers, and they don't want to forward the packets back through a load balancer. They want to send it right directly back to the client, and that achieves a more efficient service routing. And also, it uses less CPU than kubeproxy, keeping the data plane in sync. So it's all just in general, it's like less CPU, less resources, faster, higher performance. And then, so this kind of is an intro into that. And there's a video where we gave a talk at the CNCF. I think Sean gave this talk. It's really one of our developer advocates. Is a really good talk. And then if you just want to learn about eBPF in general, you can come here and kind of educate yourself on eBPF. We're about 5 minutes out. I think we have one more question here, and then we're going to call it for the day. I actually, just before we get to that though, I've gone through the lab that we went through here a moment ago in previous trainings. So if you want to look at one of the past videos where I actually go through it, feel free to do that. In one of the next versions of this on-prem case, I'm actually going to go through and actually show how to peer with top rack switches using some Cisco NXOS, Cisco the 9000K devices. So if you were hoping to see that, come check back next time you see the on-prem, getting started with on-prem, because I'm going to do that then. All right, one last question. We have an issue in our production environment. We're using Cisco ACI to power a network, and we suspect some IP spoofing from IP pod private net when traversing physical firewall. For outgoing traffic, net is performed with IP tables. What could cause this issue? Can overlapping network between destination servers no causes? So I'm not sure what's actually happening in your environment based on this description. I have worked with some customers that use Cisco ACI. If you're keeping your cluster private, I think Cisco does some learning of MAC addresses based on the traffic that it sees, and I've seen that become an issue with Cisco ACI. If you wanted to, what I would suggest you do is hit us up on our Project Calico Slack. And where'd it go? Let me come back here. So what I would suggest you do is join us on Slack.Project Calico and ask that question there, and then we could probably help you dig into that, and we'll have some of our engineers will be on there, much smarter people than me, can help, and who are very familiar with Cisco ACI can help dig into that. If you are peering with top of rack switches with ACI, I know that there's like I think it's either BGP out or route out interfaces that you would want to use. But hit us up on Slack and we can dig into that a little bit better, a little bit further here. So that's it for today. Thank you very much for your time. Appreciate you joining us. Again, keep an eye out for the next trainings that we're going to be doing here. Tell your friends. Follow us on our YouTube channels, and hit us up on LinkedIn as well. We're constantly publishing blogs and new information, so follow along and stay up to date. Thank you very much for your time.